Hello, student. I would like to start a very important lab lecture and very interesting LABLecture 5, related big data. So during this lab lecture, I would like to focus to the big data section and doing some hands-on exercise using Spark, very important platform for big data. As you remember, we had many lab lectures. This lab lecture related big data, we already covered many other lab lecture for AI. Now I would like to focus for big data hands-on exercise. So through this hands-on exercise, practically we will do some Spark, Apache Spark, implementation using the real data, and I will define some scenario. Based on that scenario, we will do some practical, coding through the Google Colab. So let's dive into big data exercise, hands-on exercise. So as you remember, we already had a discussion, very detailed discussion for a Spark platform in the lecture part. In the lab lecture part, first, quickly, I recap some important concepts regarding the Spark, and then we will touch some practical part. So you remember what we need in the hands-on exercise. We need some attention to data abstraction in Spark. And you remember that data abstraction, for distributed data processing, data abstraction provides some logical representation, means logical modeling for data, because in data abstraction, we are talking about the big data, right? And transformation. So data through the distributed system, how transfer from one place to another place, we need some logical, representation. First, we need some logical representation, and then go for physical representation. You may remember for any sort of modeling, for any program development, usually we need several steps. One step is the conceptual modeling. Actually, one is the external modeling in your mind. Maybe several person has external modeling for same issue. For instance, you consider that you have a big, warehouse, and including many stores. Those stores selling many products connected your warehouse. You want to design some application, including big data, even application. Many people has external modeling. Then when you come to the conceptual modeling, conceptual modeling, every person should be unique, but many people may have different external modeling. But when they come to the conceptual modeling, using the UML or any other language, coming to the unique conceptual modeling, then you need to do some logical modeling, logical representation, logical modeling, and then you will deal with the physical modeling. This is the general steps you already know for program development, basic design, engineering basic design, algorithm development. Always this is the steps. So here, when we say data abstraction, as you see the logical representation, this is the logical representation. Representation and modeling is the same. So we are in this step. So when we have some conceptual modeling, for in our case, we are going to work for some online retail warehouse. So I will define some scenario, and imagine a global retail company operating across multiple regions with sales data stored in distributed data center. So imagine we have one data center in North America, located in, for example, New York, city in USA, which cover North American country like USA, Canada, something like that. And we have for our retail global company, we have another data center in Europe, European data center, for instance, located in Paris, which handle France, UK, Germany, Spain, and other European country. So this sort of exercise to manage that one. You need to consult with different company already have experience, retail company, global retail company. You will get different. Then you will design your own conceptual model. How many elements you have, how many sections you have, which sort of data you have, which sort of function you have. Then you need to do logical, modeling, logical representation. So now this is this step for logical representation, and then you will use some Spark to implement it. Some AI and big data management. This is physically you will use some development. You will do some programming. You will use some software. So I hope now you understand what we are going to do. So why we need this data abstraction? Because that is many complex issue will be simplified. And this is for distributed data, you need some sort of logical modeling for scalability, for fault tolerance. Data abstraction is very important. That makes flexibility, support various data type, and many sort of processing like batch and streaming. You may remember for data, big data processing, this is the two part. And then we need to optimize our performance. So later on, we will talk about the Catalyst optimizer and DAG. This DAG is good for optimizing. So data abstraction is very good for manage those issues. Okay, well done for until this step. You already support me and follow me. Let's go. Just put some important slides from the lecture part, which we need for our practical part. So just remind you, we already had a discussion for RDD and data frame and dataset. I already mentioned these three is very important and fundamental, and three options. This DAG and SQL, Spark SQL will support these three. And the oldest one, which is usually is for for low-level abstraction, and usually for some sort of low-level abstraction, usually for unstructured data. So this is the very earliest data abstraction in Spark, as you saw in the next you can see this is the earliest 2011 start. And then come to the data frame later and data set. So data set support data frame and RDD. So this is the newest one, and this is the four three main fundamental which follow same structures. Later on, Spark SQL SQL totally new sort of view, query structure based data, which much better than these three, covering all of them as a basic platform. So this support unifying declaration abstraction. So this Spark SQL is not a standalone abstraction. Like, please look at here. This is very nice sentences. So that Spark SQL is not, we cannot compute here because they are a standalone abstraction. We can use those. You will see in the coding that in the coding we will use these three abstraction standalone. So Spark SQL is not like that, but it is served as a unifying declaration abstraction. So for structured data, enhancing the usability and accessibility of Spark data processing. So for three fundamental and standalone abstraction, remember RDD, data frames, and dataset. So during our hands-on exercise, we will use many sort of coding related this one. And I will show all of code related to these three fundamental, abstraction. So data frame is the high-level abstraction for structured and semi-structured data, but RDT usually is for unstructured data. And we will talk later on about the schema and data abstraction. You will see that RDD no need create for, if you use this data abstraction, you need to make a schema and modeling. But if you use the RDD, you don't need a schema. So because RDD can directly process raw data, so RDD does not need a schema, only work with the raw data. So what is the schema, and what are the difference between the schema and data model or data abstraction? I will talk later. Okay, so you please, this slide is very important, and remember these three. And a datasets is combination benefit of these two. So this is the old one, lower level. This is the higher level. This is combination of that one. And as you may remember, one of the advantages of the dataset is the type safety. Type safety, just explain and remind you what we already discussed, means data type. If our data type is different, for instance, you want to do some analyzing, which is using different data type, it may get the error. But if you have this sort of line, maybe you pass several line declaration, come to some error. But if you have many compiling happen, for instance, you define x equal 1, or another, like for example, university variable, then you put the for instance Sejong University. I cannot write it down. So Sejong is a string, and this is an integer. So until here is okay. But if you say x plus university, what is the result? This is error, because x is a number, university is the string. So here would be error happen. But if your environment data abstraction has a type safety, will not let you compile your program reach to here. From the beginning, program will be a stop. So you will save many time, many compiling, processing. So this is the advantages of datasets. So dataset has unified abstraction, offering data safety with the optimized execution plan. So already we talked about the DAG, which is the acyclic, means not directional graph. Will be shows what's happening during the Spark, which sort of transformation and action is happening. So these 5, remembered, which 3 is the standalone. Okay. This is the history we discussed before. RDD, we already talked. This is the lazy evaluation, means keep the classes and run it when needed. So, and Spark is a in-memory computation. For data frame, we already talked that data frame use the catalyst optimizer and using the SQL-like query. So that's why here Spark SQL come based on the SQL. Data frame also based on the SQL like syntax detection, and is integrated with the structured data. So data set, remember, data set is having advantages of both other data abstraction. So we are going to now do implementation using these two. So is including type safety and combined base feature of RDD and data frames. So when you have a data set, you will have advantages of each data abstraction. Limitation that this has no available for the R and Python. So this is the problem for this one, this abstraction. Spark SQL we already talked. So provide the runtime syntax error. The checking. So graph, this is the looping means direction. This is not directional. And then this table was a comparison. We discussed a lot before. Just remind you, type safety, RDD, comparison, performance, easy use. You can refer to the lab lecture video and some more comparison. Okay, now let's start hands-on exercise. Okay, for Spark workflow, you already start to show any Spark transaction start from users, maybe several users distributed in different places. Each user partitions. Means, for instance, if we have a data, this data divided to several places by partitioning, and each data come to the some cluster. This cluster can be many partition inside. In each partition, you need to do some task on that partition. So that cluster managed by executor, several cluster managed by a cluster manager, your application managed by driver, and other detail we will see later. So the cluster management, executor, and driver. Already we explained that driver try to, this is the in case of the RDD, but can be data frame or data set, you remember. So any partitions can be deal with each cluster. So remember, here is the Spark session. In a Spark session is the driver exist. So here this part including driver and Spark session, including many Spark session. Spark, this is the old version of the environment for initiating the Spark in the user side, Spark contest, which can divided Spark session. So every user here can deal with the executor. So the cluster management allocate resources. Resources means executor. So executor on each side of cluster. So execute a task means when we are saying execute task, mean execute two things: transformation and action. We will talk later. So this is two important part. So we already talked about the job driving, transformation and action, which is, any Spark job consists of two parts. Transformation means like map and filter. Action, do some action like show, save, collect. So usually in around the data abstraction, RDD or data frame or data set, this here is RDF. Transformation is inside some, as here mentioned, operation to create new data abstraction for existing one. But this is action is a trigger actual computation. So here is some sort of definition and some sort of logical preparation. This is the physical action which you need to do. And we already talked about this part. Let's go. Players is the driver, executor, cluster manager, and Spark context and or section. So remember, we have a logical part and we have a physical part. So these two tables, remember, many times we will refer to these two tables. So for a Spark project, we will start all of this. So one by one, we will go inside and see what's happening inside. Okay, to manage this hands-on exercise, I prepare one document, hands-on document. Simultaneously, we will go to the Google Colab and manage that one. Okay, let's start a hands-on exercise for Spark workflow. In our example, we are going to talk about the real real example, real scenario for retail, business. So as I explained before in the, PowerPoint, there is a 12 step to run any Spark project. So there is some initialization phase. before we dive into the several steps of the Spark project. So we need to, for the dataset pre-processing, and we need to define our data center, how many partitions we are going to have. So that means how our data distributed in the world. During that project, we need to little bit talk about the data center and partitioning logic. This is at the beginning we will start to talk, and then one by one, step 1 to step 12, we will do it to show you the real Spark project. Okay, let's dive into hands-on exercise. So let's first talk about the scenario. What is our scenario for the project? This scenario, many times I change the scenario to make very interesting and real scenario. So we are going to use the real data as well as scenario is very match to the big data characteristic. So what we are going to use, retail analyzing for multi-region. So please, word by word, I intentionally put that words, and you should understand. So that's why I decided to show the main file, which would be helpful for you. Imagine in this exercise, a global retail company has multiple region, which sale data store in a big data storage and distributed through 2 representative. I decided to have two different data center, one in North America, another is a European country. So I put, you can decide for the real project, this part is the pre-processing in terms of selection of your data center. You can decide where you need to put your data center. So I decided to put my data center in the Paris and the New York. This is close to the North American country, which is like USA, Canada, and the European country. Paris can in the Central Europe. Paris is a good as a center of Europe, manage like UK, Germany, Spain, the others. So what is the goal of the project? So the goal of the project, we are going to calculate average sales of the product by category, by country. So depend on which sort of searching algorithm we are going to do. We define the data center. Since this is the big data processing using the Spark, we need to ensure that not error happen between the data center, because we are going to collect sales data. Remember, sales data, which is distributed several places through one data center manage, and so we have a 2 data center. So maybe in the USA has a many local sales department, or country like other country, Canada. This is the data center 1. We call it NA data center. I decided to make it the abbreviation. NA stand for New York, and NA stand for North America, and the EU stand for European country. So this is the second and third objective. We need to use the partitioning. When your data is big, so if this is your data, you need to divide your data, because each data come from several places. So this data can come. So then you need to, or sometime you do aggregating. So you have this data, you make a 3 partition. Then every data for this data, this section data is for whole Europe. This portion is for whole North American, and this data, for instance, for the Asian country. So this is the business goal of this project. So I decided to have, if you go to this link, you can type this link of the project. you can access to the real dataset. You can download it. This dataset including some information, several data is like 8 column. Some column string, some column data is a integer. So the file, which is CSV format, and the name of the file is online retail.csv. If I open that file, so this file contains sales record with the field of the country, stock code, quantity, and unit price. So let me open the file. So this is the file. You see here, this is the invoice number, stock code, so description, and quantity. This is the invoice date, unit price, some customer ID, and the country data collected. If you see the country, this is really big data. Country like UK, you can see like Australia, like Canada, many, Netherlands, France. So the data is regarding that, as you see, 540,000 record. So really is a huge data. So we are going to do a big data access to this data. This is the real data. So do some Spark big data processing. Okay. So consider, after we check and dive into the data set, after that step, we need to little bit talk about which sort of analyzing we are going to do. So first of all, we need to partition data across the cluster. We need to optimize computation, minimize shuffling. Shuffling means, transferring data from users to data center and to the main, data processing part. Shuffling should be decreased. Many shuffling, because many internet bandwidth and computational time. Many shuffling means many data transferring is not good, so we need to reduce it. We don't need to do transfer between the node, so we need to find optimized algorithm. So the efficient way is solution for minimize shuffling means calculate the average. So perform distributed calculation to minimize the resource usage. For example, nodes calculate local sum and count. So instead of transfer every record, at the first step, we can send some sum of data or count of data instead of real data. So central node compute the global average using the aggregated data, avoiding needs to transfer entire dataset. Instead of we send entire dataset from the every local part to the data center, we will use some average technique. So each node calculate total sum, and then only aggregated value, for example, sum or count, will be sent. Central means those data center will calculate global average using total sum. And each node do it and then send to the data center. This is good for controlling the, shuffling and minimize the shuffling. So this is good for streaming calculation and distributing algorithm. That would be great. Okay. Let's do, initialization phase. So usually when we receive some data, if our data is not good, if are created by ourselves, or sometimes we receive some data, we need to do cleaning, transforming, means format, timestamp, normalization takes some time. For doing so, we need to use the pandas or numpy. We already work, and doing sometime by Spark processing, doing some pre-processing, that would be good. So when we in the initialization section, after data pre-processing, we need to do set up the data center. So we need to set up our data center. So to do, because we already need that one. So I already decided North America and European, but you need to know which sort of data set I decided. For example, data source, location, business requirement, infrastructure and cost, regulatory compliance, fault tolerance. These sort of characteristic and criteria would be very important when we would like to do data center host choosing. So first of all, data source location, process data closer to its resource, reduce latency. We will have a less latency delay. For example, for USA and Canada, it is not good we use in Europe. It is better used in one city which can cover several center. So business requirement, sometimes assign data center based on their regional team needed, or sometimes we choose the location, means data center, based on some reliable infrastructure, some platform is available, or sometimes there is some rule like GDPR for Europe. Then you will decide based on that region regulatory, and also some fault tolerance and redundancy. Avoid redundancy. We will choose a data center. So after that, we decided to have this one, New York in the USA and Canada, and partition. We defined 4 partition. We divided, for example, each data center has a 2 partition. You may remember that partition is different. The partition is for data processing, data center for keep the data. So the question comes, how we decided to how many do partitioning. For instance, in this exercise, I did 4. So to do so, I wrote some text. Designing partition logic. Usually, partition divides data into a smaller chunk for distributed processing. Because if you have a chunk data, you can decide what you can do later. So why partitioning are important? That is because enable we can simultaneously processing across the network. This is when we use partitioning, reduce shuffling by keeping data close to the processing data. So data we have, we don't need many shuffling, and this can accumulate through the scalability matter. So here, and for partitioning, you should consider that several points. One is the data set structure. This is dependent. When you want to do partitioning, you should look at your data. For instance, in our data set, we have a country and a stock code. So based on our data, country and stock code is good for partitioning. Based on the country, you do partition your data, and based on stock code. So in our data, online retain CSV, stock code represent product category. So, and the country represent region. So should be something tangible and differentiable. So how you partition, you should look at your big data content. So when you partition, should be balanced within a fit to memory. Not make big partition and a small partition. Many, for example, country in one partition, but less country is another partition. You should have a logic, another point. Partition by frequently query field. For example, grouping by country, reduce shuffling during aggregation. So you have some logic. Number of partition, usually 2 times or 3 times of your cluster core, because each cluster, each hardware or cluster has a core, your computer. So if your computer has a 16 core, 2 or 3 times, means 32 or 48 partition. This is the somehow rule of thumb. Usually they do like that. So see here, for instance, we have based on the R data. If we go for partitioning, it would be better we go for country. Say, okay, for North America, USA 1 partition, Canada 1 partition, and in EU, France and UK 1 partition, other country another partition. Or if you do like that, then range of stock would be like this. So because this has more than 50, 50,000 stock code, so that would be more than 50 is 75. So then you need to and if you see the code start from, let me bring the table. So here you can see, if you do it, some sorting, you see from 10,000 start, then this will be go, you will have this will be continue 22 many others data, because there is another country. So stock code to several level exist. Okay, now let's back to our discussion. So there is a question here that what is difference between meaning between cluster and partition? To understand that one, I try to wrote some point which I thought maybe it is useful for you. Cluster is a physical or virtual server managing multiple partition, one cluster. But partition itself logical division of data within cluster. We need to do for parallel processing. So partitioning strategy sometimes can be do via region, sometimes can be do by range, like a stock code based on our data. If your data is another one, then you need to decide which field is good for partitions. So this is the point which you need to consider. Okay, let's go for step 1. It is the 12th step. So in step 1, we need initialization for every Spark application. And this is, Spark runtimes and connect driver to cluster. So you remember this figure, that driver and connection with the cluster. So that initiation, you need a Spark session. So as you can see here, a smart context including a smart section for many users using, and connect to the executor is inside cluster. So remember, previously for Spark version 1 only use a Spark context, but for new Spark using a Spark section. So this is for connection between driver and for users. So driver initialize the Spark application, connect to the cluster manager. So a smart session is the unified entry point. So as I explained, what is difference between a smart context and a smart session? The difference is that is for old version, only for RDD operations, but for many new data abstraction, a smart 2 point more than 2.1, 2.3 something, is a smart session and support every data type. So the driver represents central server in the company global headquarters that manage the analyzing job. So cluster in the France and USA are connected because NA cluster in the New York and EU data center. This is data center. So this will be connected. Cluster will be all cluster connected to the data center. So what you need to do? Only you need to use this code. So I am going to explain. First of all, we need to bring the PySpark library SQL, the last library, and use the Spark section. And I put some more explanation. For example, for initializing a smart session, you need to put some name. First of all, you need to create a smart section. This is the first part, and you need to put some name. And there is a two option. Master depend on your server, and here there is a two is a get or create. So this for the local. Why we need use the local? This is specifies deployment mode. When we use the local, that means Spark will run locally using all available CPU cores. If you are running a Spark on a cluster, this value would point to cluster master URL. For example, if you are using a Yarn or a Spark, you need to put host name if you are running this on the cluster. But if you use the local, that means a Spark will run locally using all available CPU cores, or you can change it. So get or create new smart section if one doesn't exist, or retrieves existing session. So if you have an existing section, it will be used. If you don't have, depend on how many section based on the user, you will decide get or create. This is let's go to the Google Colab and use this code. And after you receive in the message smart session initializing, means you successfully done this process. So let's open the Google Colab. Then you need to make a you need to workflow. You can make a space. Then hands-on exercise. So for LABLect5, before you call the library, it would be better you pip install PySpark. So it is better first install PySpark and then do initialization. And then you need to initialize, means you call this Spark session as a entry point to the programming Spark with the dataset and data frame and API, so it can be used and create. So we created, successfully done this stage. Let's back to our exercise. And remember why this section is important, because all Spark operation, any operation of Spark, like reading data, any things which you want to do, or running transformation, performing action, because there is a two thing in the driver part, transformation and action. We need a Spark section. And Spark section manage the life cycle of a Spark related process, including resource allocation, interaction with a Spark cluster or local environment. So this is some sort of unified interface. whether you are working with a data frame or data set for data streaming, Spark sessions serve as a unified interface. So this is very important. Okay, we finished step 1. Now let's dive into step 2. Step 2 means we create a schema or data model, which is optional, depending on the situation. First of all, let's discuss why we need data model. When we work with the structured and semi-structured data, for unstructured data, we don't need. So this is the point. But for semi-structured data and structured data, if we define a schema, this is better control and efficient, performance. So for structured data, usually we use structured data. Remember, we use data frame and data set. For unstructured data, we use RDD, tree data abstraction. We already discussed. So for doing so, a structure type, which is good for data frame, and case classes is for data set. Okay? But no schema we need for RDD. We don't need any schema. So RDD doesn't need, because RDD work with the raw data. So a schema interface interfering from the first row of the CSV data can simply workflow. So this is the automatically creating a schema. So a Spark data abstraction, there is a two concept. We need to differentiate between these two. Sometimes we call it data abstraction, sometimes we call it data model. So you need to understand. Data abstraction is a specific data structure Spark used to represent processed data. We have a tree data abstraction. Like RDD, we already discussed, data frame and data set. This data abstraction related to data structure of Spark to present processed data. These abstractions determine how data handled in the memory and distributed across the cluster. So simply handle in the memory, how data handled in the memory and distributed across the network, because our network many clusters. So why data abstraction good? In name, abstraction means summary. So then many complex implementation abstracted. Only relevant feature of data shows. Provide some conceptual view of the data independent how stored and manipulated. And operate at multi-level, physical, logical, we already discussed. But data model. So for data model, this is refer of a structure of data. For example, column, data type, it is applied to a structure and semi-structure, because a structure data has a structure. So data model has a meaning. Unstructured data, no structure. So no need data model or schema. Same name, schema and data model, same name. So sometimes for data frame and data set, schema are either interfered, means calculated automatically from the source. Or if you want to manually create data model using, as I mentioned before, a struct, means come from a structure, a struct type for data frame, and case classes for data set. And for a schema are the specific way to implement data abstraction. So before data abstraction, which we going to handle how data in memory, we need to do a schema. So this schema data modeling before data abstraction. So find a structure. How data organize? Simply data model. We organize data here and then handle data in the memory to do action. So step 1, step 2. So in data abstraction and in data model. So if we see the code, let's see the code now. When you are going to see For data modeling and schema, this is the for RDD. And for data frame, this is the code I'm going to explain, and for dataset, this is the code. For make a simplicity, I will work only with data frame because this is very low level, this is high level, very popular, and this is more advanced and complex one. So I decided only work with data frame. For your information, just put all of them. So color which I'm working is a blue. I make a dataset green. Any code related to dataset, you remember dataset is the one abstraction. Just for your memory, here. So I will work with data frame. Not RDD, this is low level, this is high level, simple one, and this is a little bit complex one. But I put all code, somehow I explain, but I will focus only here. So let's go to the code. You know, in RDD do not enforce require schema upfront as they work in the raw data. Instead, you can define function to parse and structure raw manually. Means we just, because the RDD data is unstructured data, in the data model part, we don't create a schema. We can just manage and parse some structure to data. For example, field one, remember we have an invoice. See here, use a custom function to parse rows into a structure, the directory and tuples. We already talked. So this is field one. We define some, for example, based on the Excel file. Let me show. Just we put, field 0, field 1, field 2, like this. We don't make a schema. Just parse some structure. So for RDD. But for data frame, as we mentioned, we use some structure, defined a schema explicitly. See here, we try to Spark, PySpark type, because we are going to give the data model and give some organizing. So we will use like a structure type, field, structure type, and integer type, some double type. For instance, for quantity is an integer type. For country is a name, a string type. So very simple. We just call this library and define the schema. We define a schema for this is data frame. So for data frame, and so we will then we will say data frame. Actually, data set here it was not that data abstraction. Data set means our data. So it was true because here means our data set, not a data abstraction. But anyway, we could say defined a schema for the data set. Yeah, this is true. But a schema defined for data frames means our data abstractions. Anyway, a structure type and just with a structure field we define. We just organize our data. And for data sets abstraction, use a named tuple or case classes for a structure and type safe data. We don't touch this part, but in case I put the code, for example, you need to define the tuple, and you need to import name tuple as a library, and then you need to do this one. This is the main thing you need to define. This is just example, and this is for each. This is the get each data. So we don't touch this one. Go for a simple one. So let's do this one in our process. So in our section, let's do. Now we will focus only data frame. Yes, schema quickly created. So this is the step 2. Remember, there is some point which I would like to mention, that schema play a vital role when working with a structured and semi-structured data. So that is very important. Spark automatically infers the schema when reading a structure and semi-structure. There is a point, sometime when you read some CSV file or Parquet file, JSON file, you don't need define because Spark automatically creates a schema. So that's why this section is optional. So when you read, especially for data frames, when you read the CSV file, automatically Spark will be created. So the point is, Spark, when you read the file, CSV file, automatically make some schema by default. But if you don't make yourself, maybe sometime error happen. And for large data set, you need to make a schema. So a schema, it is better manually do, because that is increase your precision, and your the data will be protected from the error. So this is the for better performance, error prevention, complex schema. So this is the very important. You need to do it. So I can show you one table to better understand my explanation. So here, simply, I created a very nice table. When your data set is small, Spark automatically created the schema, data model, means organized data. So this is fast, straightforward. But when your data is, large data set, or you need to do some specific organizing data for predefined specific schema, or you have a hierarchy data, then you need to use manually for data frame using the struct type. So this is avoid performance overhead, enforce consistency, and prevent event and error in the event. And for structured data, that would be good, especially like JSON or other thing. Anyway, schema and data model is very important. So that's why you need to pay attention. Let's touch another step, which is step 3. Okay, step 3 means load data into a Spark, data abstraction. So this step 3, you should consider, let's back to our table. You may remember step 3, load data. This is for RDD data abstraction. This can be data frame or data set. We already finished data, data model and schema. Here, load data. This is logical plan began. So, as you may remember, logical plan here is created. So, physical plan from step 7. So, but it's the physical, physical, logical, physical, some action. This is some definition. So when we load, the logical plan started.